Hello everyone, my name is Mayur Chawda. Welcome to my YouTube channel. Today we are going to discuss about assignment 4 SVM and Naïve bias algorithms for the subject Introduction to Data Analysis. So for this assignment, we are choosing 7 variables. So 6 of them are independent variable. So independent variable are as below: cell, cellularity of marrow clot section; smear differential percentage of blast; infill, the percentage of absolute marrow leukemia cell infiltrate; Li, percentage of labeling index of bone marrow leukemia cells; blast, absolute number of blast in the peripheral blood; temp means temperature, highest temperature prior to the start of treatment. And we have one dependent variable, which is remis. So 0 means no remission, 1 means remission. Let's go to Jupyter Notebook to understand the code. So as you can see, first step is to load the libraries. So we are loading pandas and numpy. So import pandas as pd, import numpy as np, import matplotlib.pyplot as plt. Second step is to load the dataset. So we are having CSV file as our dataset. So we'll use pd.read CSV function to load our dataset. In order to see the dataset, we'll use dataset.head function to see the preview of dataset. So as you can see, we have the 7 column: cell, smear, infill, li, blast, temperature, and remis. Now let's go to training and test dataset. So for that we are creating x and y variables. So for x variable, we'll be using dataset except remis column. So we'll drop the remis column from our dataset and use this all the columns as x. And for y-axis, we'll use the remis column. Then create training and test dataset. So for training and test dataset, we'll using from sklearn model selection import train state split. Then use the code to train and test the dataset. So for random state, we are using 65, and scale the data. We are using sklearn pre-processing. We are importing standard scalar. Now for using algorithms, we have two scripts, SVM and NV, Naïve bias. So from sklearn.smv import svc, from sklearn.naïve bias import Gaussian NB. So from sklearn.matrix import classification report and confusion matrix. So these are the two algorithms we are using. First one is SVM, second one is Naïve bias. So we are using method kernel and kernel for SVM, which is linear, and for Naïve bias we are using Gaussian NB. For SVM we are using random state as 65, and we're printing the confusion matrix and classification report. We can see the classification as below. Now let's go back to the PPT to understand the precision and confusion classification report. So these are the key insights from classification record for SVM. So first one is precision. How many are correctly classified among the class? So for class 0 has higher precision than class 1, which is about 25%. The macro average of precision is 6.62 and the weightage average of is 0.67. So recall how many numbers do you find over the whole number of elements of this class. The macro average and weightage average of recall are 0.62 and 0.67 respectively. F1. Harmonic mean between precision and recall. The macro average and weightage average of F1 score are 0.62 and 0.67 respectively. The accuracy of F1 score is 0.67. So key insight from classification for naive Bayes algorithm. So first one is precision. How many are correctly classified among the class? So class 0 has higher precision than class 1, which is about 20%. The macro average of precision is 90.90 and weightage average is 0.87. Recall, how many numbers do you find over the whole number of elements of this class? The macro average and weightage average of recall are 0.75 and 0.83 respectively. F1 score, harmonics mean between precision and recall. The macro average and weightage average of the F1 score are 0.78 and 0.81 respectively. The accuracy of F1 score is 0.83. Comparison of classification report. So for comparison, as we can see, the precision difference in the classification using SVM is 25%, but after classifying the dataset using naive Bayes algorithm, it decreases to 20%. The accuracy of classification using a SVM is 67%, whereas it is 83 using a naive Bayes algorithm. Now, reasons of choosing naive Bayes algorithm. First one is precision in SVM model is decreases from class 0 to class 1 from 0.75% to 0.75 to 0.50, whereas it is increases in the case of naive Bayes algorithm from 0.80 to 1. The accuracy score in naive Bayes algorithm is 83%, which is far better than SVM model accuracy of 67%. F1 score is higher in naive Bayes algorithm than SVM model. As per the above three advantages, we will suggest naive Bayes algorithm to Mr. John Hughes. Thank you.